Hello guys and welcome. So in this video, we are going to understand how the tier 3 ISP is going to build an SD-WAN fabric over the tier 2 ISP's MPLS core network. So breaking down the core network for the tier 2 ISP, we are going to have OSPF as the convergence protocol. Then we have LDP as the label forwarding protocol. Then we are going to have BGP VPN, V4. So basically, all these constitute the MPLS core network. Now, when we come to the tier 3 ISP side, the tier 3 ISP would have a data center where the controllers for the SD-WAN fabric is located. So we have the VBON, which is going to act as the orchestrator. Then we have the vManage, which is going to act as the management plane for all these devices, the vEdges. And then we're going to have the vSmart, which is going to act as the control plane for our vEdges. So basically, when it comes to routing decisions and everything, policy filtering, and then prefix filtering and everything, when it comes to routing, with respect to routing, vSmart is going to take care of that. Now, understanding how routes are going to work, or let's say we have these devices in different geographical locations. So we are going to understand how it's going to work. Now, first of all, let's understand how MPLS work. So for MPLS, every customer has their own routing table with the help of a VRF. So this interface is going to be in a separate VRF for the tier 3 ISP. So as well as all interfaces for that tier 3 ISP. So they are basically connected to our MPLS core network, or let's say the tier 2's MPLS core network through VRFs. So once we have the VRFs in place, routes from this side or any routing down towards here. So obviously what I did was that I've configured a static route pointing to all the subnets here through this VRF for tier 3 ISP, and it has been redistributed into BGP. So BGP VPN v4. So any route from here, from this side, is going to be redistributed into BGP VPN v4. And then the device over here is acting as a route vector, which can also, in this case, is also acting as a P. And then we have our P here, provider edge device, P. So any route being received from here locally is going to be transferred all the way to this side. So we have the same routes. So any route reachable from here is going to be reachable from here as well. And then it's also going to be reachable from here as well. We will check the configuration as well, so you don't worry. And then we have the interfaces connecting to the various vEdges. Now, these interfaces, or let's say any route or prefix between these vEdges and the provider edge devices must be reachable. That's why we are using the VRF to redistribute into BGP VPN v4 so that all our Ps can receive it, so that each VH can get the TLOC routes for the other. So the TLOC routes are actually the routes that builds the the SD-WAN overlay. Okay, so we have this particular prefix. Once it is received from here, or once it has been redistributed into the MPLS core network, we're going to get it from here. So this device is going to get the TLOC route, let's say how to reach this site. That is the TLOC route, the transport locator. So same applies to here. This device over here must be able to know how to reach to this device as a TLOC, and then vice versa from here to here as well. So they must be able to identify each other within the SD-WAN fabric. And now all these routes as well must be reachable from the data center where we have our controllers. Now, what happens is that when these devices come up, Now, when these devices come up, okay, when these V edges come up, the first thing that they do is that they're going to look for the V bond. So once it come up, it's going to look for the V bond. Why is it looking for the V bond? It has to look for the V bond because the V bond would have to authenticate the devices and make sure that they are authorized to be on the network. When it happens that way, once authentication is done, the V bond is going to give to the V edges the IP addresses for the V manage and the V smart. Once that is done, what you're going to have is that the V edges is going to build what we call a DTS tunnel or to here, and then one from here to controllers. So a DTLS tunnel all the way from here to here. Sorry, this one is top part. The DTLS tunnel will be built from every V edge to the controllers over here. Okay. So now we need these DTLS tunnels to establish a secure channel of communication to the controllers. Okay. Once everything is done, what we are going to have is that now the V edges are going to establish IPsec tunnels with each other, and then they form what we call the full mesh. So after authentication, everything, the SD-WAN fabric is going to form a full mesh where the V edges by default can receive routes from each other. So from the server side over here, are going to receive routes. So all these, the server side over here is going to redistribute this server side routes through OMP into the SD-WAN fabric so that there will be a full mesh within the SD-WAN fabric. So basically, that's how it's going to work. I'm not going to configure this lab. I've already done this lab, and I will leave a link to a bootstrap configuration, or let's say a bootstrap lab where I have configured all these devices. All you have to do is to actually know how to do your routing, whichever way you want to do it. All you have to make sure is that the SD-WAN fabric is up, and then every device can reach every device. All the routes are going through. I'm not going to go down to how to configure MPLS, BGP, or whatever. I have done the configuration in the SD-WAN lab. You can choose to use a direct connection just for the routes to work. You can choose to use MPLS VPN to let it work for you. So in my next video, we are going to do verification. We are going to log into the devices and check the configurations from the tier 2 ISP core to the tier 3 ISP core, just to make sure that all the routes are going through before we jump into configuring the SD-WAN fabric. Thank you for watching this video, and see you in my next video.